Okay, for question 1, it's asking us which equation is represented by the accompanying graph. So if I take a look at this graph, I can see that I have two constant functions. So this graph appears to be the line y equals 2, and this line is the line y equals -1, with domains that are not all real numbers. So if I take a look at my choices, first I just want to make sure that those choices are available to me. -1 and 2. So all of the choices have the correct constant function. So now I really need to look at the domain. So my fence is happening here at x equals -2. If I look at y equals -1, that part of the graph is going to the left of -2, but it has a closed circle. So this part of the domain appears to be x is less than or equal to -2 because it's continuing to go out towards -infinity. And if I look at y equals 2, that constant function, there's an open circle at 2, and it's going to the right. So that would be x is greater than 2, and again, that's going out to a positive infinity. So now I just need to match up my domain. So when f of x is equal to -1, x is less than or equal to -2, so that narrows it down to choices 2 and 4. And then I have to make sure that for f of x equaling +2, it's only greater than -2, not greater than or equal to, because it's not inclusive. Then it wouldn't be a function. Okay, let's move on to number 2. We're evaluating the piecewise function at the given value for the domain. So they're giving me h of -3. So I need to ask myself, in which part of my piecewise function does -3 fit the domain? So is -3 greater than or equal to -3, or is -3 less than -3? Well, -3 can't be less than itself, so we're going to go into the second piece here. -3 is greater than or equal to -3. So I'm plugging -3 into 2x plus 3, which would give me -6 plus 3, which would simplify to be -3. Choice 4. Number 3, what are the domain and range of the functions shown in the graph below? So for domain, I'm looking at my x values. I'm looking from left to right to determine my domain. So if I look at my graph, the point all the way to the left would be the x value of -4, and that is a closed circle. And if I go all the way to the right, I see an arrow, again, pointing to positive infinity. So I could say that the domain would be x is greater than or equal to -4. For range, we look from the bottom of the graph to the top of the graph. So for my range, I can see that the most bottom piece, or the lowest y value here, is +2. But then as I go up, again, I see that arrow pointing towards a positive infinity. So I could say that my range is y is greater than or equal to +2. Now I just have to find my choice. Domain, x is greater than or equal to -4, and y is greater than or equal to 2 for my range, choice 2. For question 4, they're asking you which of the correct equations represents the function f of x shown in the graph above. So what I did was I went to my calculator. If you forget, if you don't recognize it, type in each choice. When I typed in the cubed root of x into my calculator, I saw a graph that resembles the one in this question. You also could check your table of values to make sure that these points are in the correct table. But this was choice 4. Question 5 says, if f of x is equal to the absolute value of x, that's the parent function for an absolute value, which graph would represent g of x, which is f of x minus 4. So I have an inside shift of a -4. So inside shifts are horizontal shifts, and they always go in the opposite direction of the number. So we're going to go horizontally 4 units to the right. We're going to the right because it's opposite what that -4 would make us think. So the only one that looks like it's going to the right would be choice 1. This looks like it went over 4 to the right. Graph 1.
Okay, so number 6 asks us, the graph below shows the time it takes to box a certain number of items that need to be shipped. If you have 4 hours to send out the next shipment, okay, sorry guys, someone came into the room. So they're asking us if you have 4 hours to send out the next shipment, how many items can be boxed. So if we look at our graph, our we have an closed circle, on 300, and it goes to an open circle on 400. So if we look at our options, we want to include 300, but not include 400, so that would be option number 2. Okay, for number 7, they want to know which graph matches the function f of x equals the square root of x minus 1. Now we have our minus 1 on the outside, so that means that we're going to have a vertical shift up or down. And since this is a negative 1, that means we're going to shift down 1 unit. So if we look at our graphs, the graph that has a shift down 1 unit would be number 2. And if you forget what kind of shift that would be, you can also check your calculator and make sure that that function matches this graph. So for number 8, a function is graphed on a set of axes below. Which equation represents the graph shown? So we see this graph here is our cubic, and this one here is our absolute value. So I'm going to look at our absolute value first. And so if I look at my absolute value graph, normally it'll start right here on the vertex. We should see we have a shift to the right 1 and down 1. So that would mean that we would have a negative 1 on the inside, because that's opposite, and a negative 1 on the outside. So we could eliminate choices 2 and choice 4. Now, if I look at my cubic, my first graph here, we see that it has a domain from -6 to -2. So the option that has that as our domain would be option. Okay, so number 9 wants to know which graph represents this piecewise function. So our first part of it is our absolute value function, and they're saying that's when x is less than 1. So if we look at our graph, option 1, that would work. If we look at option 2, that would work because we have our absolute value graph. Option 3, this is our quadratic over here, so that could not be it. And option 4, we also have a quadratic over here, so that cannot be it. If we look at our second option, our second part of our piecewise function is the square root of x, and that's when x is greater than or equal to 1. So our square root function looks like number 2 here. Number 1, again, this is our other half of our quadratic, so that cannot be it. And our answer is choice 2. Number 10, it says the graph below was created by an employee at a gas station. So the graph is representing gas sales with the cost of gas in dollars and the number of gallons. They want to know which statement can be justified by using a graph. So option 1 says if 10 gallons of gas was purchased, $35 were paid. So if we look at our graph at 10 gallons of gas, if we go up, 35 would be right here. So that would be right below where our graph is. So that cannot be our option. Option 2, for every gallon of gas purchased, $3.75 was paid. Well, if we look at 1, that's not really a nice point, so we can't really see where that is. So if we take our graph, we take a point that is a nice point that we can see, like this right here. We have 15 gallons of gas for $4. So if we want to find out our unit rate, we could do 15 divided by 2. 15 divided by 4, that is, and we would get 375. So that would show us that for every gallon of gas, it would be 375 was paid. So option 2 would be your answer. If we just look at our other options, just to make sure, for every 2 gallons of gas purchased, $5 was paid. Well, if we look at 2, it goes a little bit above 5, so we know that cannot be it. And if we look at option 4, if 0 gallons of gas were purchased, 0 miles were driven. So this is showing us the cost. So we don't know how many miles were driven because our graph is not representing that. We're just representing the cost and the number of gallons. So number 4 would not be it either. Oh, now I remember.
Okay, for question 11, it's asking when 2x minus 3 squared is subtracted from 5x squared, what is the result? So that means 5x squared is my leading term, and I'm subtracting this binomial being squared. So first I have to actually square the binomial before I can subtract. So this is going to become 5x squared minus 2x minus 3 times 2x minus 3. You can choose to distribute or use the box method here. So if we distribute, we would get 4x squared, that comes from 2x times 2x, minus 6x, minus another 6x, plus 9. Notice how I kept parentheses around the entire polynomial because we are going to then later subtract it. We get 5x squared minus, I'm going to simplify my like terms. So I get 4x squared minus 12x plus 9, which now when I distribute that minus sign, all of my signs will change. So now it's a negative 4x squared, positive 12x, and a negative 9. And if I continue to simplify and combine like terms, my only like terms now are my x squared terms. So 5x squared minus 4x squared gives me 1x squared plus 12x minus 9. And that is choice 3. Okay, I'm just going to erase this part so I have room to now look at number 12. Okay, number 12. We're being given function f of x, and they want us to state the interval where the function is positive. Okay, so I used a different color here because positive and negative is going to be above or below the x-axis. So if I first look, again, this is my x-axis, okay, my y-axis, anything above the x-axis is where my function is considered to be positive. So everything up here. Now the function is neither positive or negative on the x-axis. That is where my function is 0. So I want to take a look at these values of negative 4 and 0. When my function is greater than negative 4, so when x is greater than negative 4 but less than 0, and that would look like this, negative 4, that is where it appears that my function is positive. For all x values greater than negative 4 and all x values less than 0. Again, not included. So that would go over here for the integral in which it is positive. Now if I want to take a look at where it is negative, I can think about this piece. This is negative, it's below the x-axis, and this piece is where my function is negative. And where that is happening, on the left of x equaling negative 4, that would be where x is less than negative 4, and over here would be where x is greater than 0. So since it's happening in two places, I would say the intervals where it is negative would be x is less than negative 4 or where x is greater than 0. Okay, question 13 says they're giving us a table of values that shows the value of a car over time. They tell us that the car is losing 15% of its value every year. So they want us to write a function that represents v of t in dollars of the car after t years. So that means I want to use v of t and show that it's equal to this depreciation. So that's what's happening. The car is depreciating, it's losing value. So let's just think back to our formulas where we had 1 plus the rate and 1 minus the rate. We subtract the rate from 1 when it's decreasing or decay. This would be exponential decay. A stands for our initial value and t stands for time. So I just want to make sure that I follow the variables of this question. My initial value would be my 18,000 because that's where t is 0. That's the initial cost. And I want to show that it's multiplying 1 minus the rate. Well, they told me the rate was 15%, so I want to convert that into a decimal, so that would be 0.15. And I'm raising it to the t because t is my x value in this question. You don't have to simplify. If you did simplify, you could write that that came out to be 0.85 to the t. So both of these versions here would be acceptable, but you did not have to simplify. All right, now we're being asked to use this function to estimate the value of the car after 8 years, round to the nearest hundred. Okay, so I have to use my equation up above, and I'm plugging in 8 for years, so 8 becomes my t. And then I'm going to just plug this into my calculator, If I plug this into my calculator, it comes out to be $4,904.82, and the decimal goes on. They want us to round to the nearest thousandth, which would be, nearest hundredth, which would be 2 decimal places, so 0.8. Okay, on the set of axes below, we're being asked to graph the function. Okay, so just to give us more information, I went to my calculator and I typed in this function f of x into my y equals the square root of x plus 6 minus 2, making sure that that minus 2 was not underneath the radical. I hit over to the right before I typed that in. Then I went to my table of values. I did scroll through my table a bit, so if you notice here, I highlighted all the nice points. So we have -6 comma -2, -5. Sorry, still highlighter mode apparently. So we have -6, -2, -5, -1, -2, 0, 3, 1, and 10, 2. So I'm going to use these points to plot my graph. So, and just one other thing to note, if we go back to our table, I'm just going to change my table set back to value I want to show you. The reason we started with -6 is if I click up in my table any further, you're going to see error because the domain starts at the x value of -6. So when I go to start graphing, I'm going to go over to -6 and go down to -2 and plot my first point. Then I go over to -5, -1, -2, 0, 3, +1, and 10, +1. And I'm stopping there only because my grid goes up to 10. Do your best to make a smooth curve, put an arrow because it would continue. However, there is no arrow on the left because the domain starts at -6. You can also notice here the shifting rule. This said go to the left 6, so that's where we are starting, and this says go down -2. So again, the point -6, -2 is that starting point. We want to state the range of the function. Well, again, remember, range says go your graph from the lowest point to the highest point on the y-axis. So the lowest point for y would be -2, and then if I go up, you see the arrow, which is pointing up towards that infinity. So my range could just be stated as y is greater than or equal to -2, or you could use interval notation and say -2, comma, infinity. Infinity is always in the parenthesis around that. Second part says state the domain, but not just the full domain. They just want the domain over which the function is increasing. So the domain in which I am increasing, well, if you look at this graph from left to right, you are increasing the whole time. This is all in an increasing direction. So we just have to remember that when I write x is greater than -6, because I'm talking about increasing, I can't include the -6, because at -6, my graph isn't increasing or decreasing, it's just constant.
So number 15, they want us to graph the function -1/2 x to the third over the domain of -2 to 2. So the first thing I did is go into my calculator and plugged my function in to my y equals. Make sure that you have that negative there out in front of you. And so now they only want us to graph it over the domain of -2 to 2. So if I look at my table of values, I only want to graph these So when I go to graph this now, I'm going to start with -2, 4, -1, 1/2, 0, 0, 1, -1/2, and 2, -4. And then do the best that I can to connect my points. Now when you graph this, make sure that you don't include arrows on the end because they only want up to and including -2 to 2. So you do not want to put arrows on that. So now they asked us a few questions about this graph. They said if g of x equals f of x, our function that we just graphed, minus 4, describe how the graph of x of x transforms to form the graph of p of x. So since we have a negative 4 on the outside, that means we're going to have a shift down. So this is going to be shifted down 4 units. Once again, that's because we have the negative 4 on the outside. Now they're asking if we have f of x plus 2, describe how the graph transformed from our original. So since we have plus 2 on the inside, since it's on the inside, we want to do the opposite. So we're going to shift 2 units to the left. So this is going to be shifted 2 units to the left. So for number 16, they give us a table that lists the salary scale in thousands with employees based on how many years they have worked for a company. The salary is for any length of time, up to and including the years of employment. So, for example, working up to and including 1 year would be a salary of $1,750. Working for 3.5 years would be a salary of $6,250. So, if we look and we start our graph, if we start at 0, if you're not working any years of employment, you're not going to make anything. So if we look, 1 year of employment is 1.75. Actually, before I do that, I forgot I need to write in my labels. So on the side here, this is going to show us our salary. And that's in thousands. And our x-axis is going to be our years of employment. Okay, so let's go back to that. For 1 year employment, our salary is going to be 1.75. So our salary, if we go up to 1.75, so that's almost at 2. Now this is going to be an open circle because if we did not work any years, we're not going to be paid. So they say up to and including 1 year. So we're going to start our function up to and including 1 year. We're going to put a closed circle there. Now if we take a look at the next one, for 2 years employment, your salary is going to be 3. So if you go up to 3, that's going to start right after your first year. So we're going to do an open circle because you're still going to be paid the previous amount up to and including that first year. Now, up to your second year, we're going to continue our line out all the way to your second year, that it's going to be $3,000. If we look at our graph, at our table for our next one, 3 years employment would be 4.5 thousand. So we're going to start going to 4.5 thousand. Once again, we're going to start with our open circle because at 2 years we're still being paid that previous rate. Now up to and including, which means a closed circle, 3 years is going to be that salary. For 4 years of employment, that's 6.25 thousand. So if we go up to 6.25, once again, we're going to start with our open circle, and that's up to and including 4 years. And our final one is 8.25. So 8.25. And we're, once again, going to start with our open circle because our previous one is included in the one before. And we're going to go up to and including 5 years. So you end with your closed circle. So the second part of this question wants us to write a piecewise defined function for the salary changes for years of employment. So we want to start with f of x equals, and we can start with our big bracket. Now for our 1.75, that was when, not to and including 1. So our domain goes from 0 to 1. We're not including 0, but we are including 1. Our next step is at 3. And that's for 1, but we're not including 1. And we're going up to and including 2. Extend this. Maybe bigger. Our next step is at 4.5. And that starts at 2, but we're not including 2. And we go up to and including 3. Next we have 6.25. That starts at 3. We are not including 3, but we go up to and including 4 years. And our final one is 8.25. And we start that at 4. Once again, we are not including that 4, but we are going up to and including 5 years of employment.
Okay, and for the last question, you're being told you have some information about a local party supply store, and the price of balloons are different depending on how many are being purchased. So if a customer purchases less than 12 balloons, the cost of each balloon will be $1.50. If a customer purchases 12 or more balloons, the cost will be $1. So they give you the function. You can see this piecewise function is written as 1.5x if the domain is from 0 is less than or equal to x, which is less than or equal to 11, and the function is equal to x when x is greater than or equal to 12, which just puts into function notation what we underlined above. Okay, so b of x is the cost of purchasing balloons, and x is a whole number. Now the reason it's a whole number is because you're not going to go to a party supply store or anywhere and buy parts of a balloon. So this is what we consider a discrete function, meaning when we plot our points, we are not going to connect them because you are not going to buy portions or parts of the balloon. So I say this a minute by typing this into our calculator. To graphs, here's my function f of x equals 1.5x, and I pulled up the table from 0 to 11. So I'm going to start by graphing that function. So I'm graphing point 0, 0. Then I'm graphing the point 1, 1.5. So you do have to graph each point. Just go in the middle if it's a half. 2, 3, 3, 4.5, 4, 6. We're going up 1.5, so you could just go up with the slope 1.5 each time. And I'm stopping at 11 for x. Okay, so I'm stopping at the point 11, 16.5, which I just plotted. Now, if we start by 12 balloons, now we're looking at this function, which is just f of x equaling x. So if x is 12, y is 12. So I'm going to start with the point 12, 12. And I'm going to go up 1 over 1 because my slope is positive 1. And I'm just going to go until the graph runs out. So that was what you needed to do to get full credit on the graphing part of this question. Then it says a customer brings 10 balloons to the cashier. The cashier suggests the total cost to purchase 12 balloons would be actually less expensive than the customer buying 10 balloons. State whether the cashier is correct or incorrect and justify your answer. Remember, justify means just the math. So let's figure this out. If the customer bought 10 balloons, they would be using b of 10, and that would go for 1.5 times 10, since anything less than 12 balloons is going to cost $1.50. So if I figure that out, 10 times 1.5 is going to cost me $15. If I want to think about what 12 balloons would cost, this is what the cashier is suggesting, that would go into the function b of x equals x. So b of 12 would just equal 12. So the cashier is correct. $12 is cheaper than $15, so we just need to indicate yes, the cashier choice. Okay, sorry. So yes, the cashier
is correct.